Hello guys, we are going to see another video of integration by parts. This is a little bit more complicated maybe. The idea is that we are going to use integration by parts just to solve a product of two functions that are special. What we are going to see here happens a lot of times, but okay, it doesn't matter. It's just a little bit longer and I hope you understand all the process. The idea is what we are going to integrate e to the x times sine of x. Could have been cosine of x, okay, for example. And I just simplify the x's. I mean, I'm not writing e power 2x or sine of 3x. I prefer just to avoid this multiplying by numbers that are going to make things a little bit more complicated, okay? So we are going to apply integration by parts to this product of functions. What are we going to need? For sure, the knowledge of the integration by parts formula, and to work with exponential and trigonometric functions. Come on, let's play. I need to integrate that function, e to the x times sine of x. And we are going to apply integration by parts. It doesn't matter how you choose right now. If you want u to be the exponential function and dv the sine, it doesn't matter. At the end, it's going to be the same. Okay? So in this case, I just chose u to be sine of x and dv is going to be e to the x. Once I just decided that u is going to be sine of x, the differential of u is going to be the derivative of sine, cosine. Now that I decided that dv is going to be the exponential function, b is the integral of e to the x, but the integral of e to the x is e to the x, so piece of cake. Now I apply the formula. Remember that this is u times b minus v du. If not, please take your look at the formula because I need it, okay? Now, what is that? b is e to the x, u is sine of x, so this part is e to the x sine of x minus the integral of e to the x times du cosine of x. Oh, okay. Okay, what happened? Normally, when we apply integration by parts, this second integral, the one that appears here, it's easier to solve. In this case, it's exactly the same level. I have no idea what is the integral of e to the x cosine of x. What can we do? Okay, breathe again, and let's see. It's a product of two functions. Why cannot apply integration by parts? To solve only this integral. Second step, then, we are going to solve this integral using integration by parts. I decide that u is going to be cosine, exactly as before. Now don't change the order, okay? If you decided the other way around in the first stage, now you keep doing the same. So I call u cosine of x. dv is going to be e to the x. So the derivative of u is going to be the derivative of cosine, negative sine. If dv was e to the x, the integral is going to be e to the x because the exponential, the integral of e to the x is e to the x, okay? So I apply the formula again. The integral of e to the x cosine of x is v times u, so e to the x cosine of x, it's here, minus v e to the x times du minus sine of x. Okay, this negative can be taken outside. So the expression that I obtain is the integral of e to the x cosine of x dx is e to the x cosine of x plus the integral of e to the x sine of x. And then, okay, what has happened? I obtained the first formula again. I'm like in a cycle, okay? I apply integration by parts, it becomes e to the x cosine of x. I apply integration by parts again, it becomes e to the x sine of x. I apply integration by parts, so we need to stop the process, okay? We just obtained the same formula from the beginning. How to finish the exercise? Okay, let's start from the, let's take back to the point when we solved the first stage. The integral of e to the x sine of x was e to the x sine of x minus the integral we just already solved in step 2. So I just replace the second integral in here, okay? So what do we have? This integral and this integral are the same. What I'm going to do is to treat this as an equation. This is negative, so I'm going to move all this integral to the other part of the equality. And it's going to be changed the sign. Okay, so I got this integral plus this integral, one chicken plus another chicken, two chickens. Okay, so at the end, we have 2 times this integral. And this part remains the same. So In this case, the 2 is going to be moved down as a denominator, and I have that the integral of e to the x times sine of x is 1/2 e to the x sine of x minus e to the x cosine of x. Okay, so the idea is to break the cycle, and when I just got this one here, I just move it to the other part, add it to the integral I was trying to calculate, and then the 2 goes down dividing. And then I know what is the integral of this expression. Is it difficult? A little bit. It's long, yes. And it's a process that you need to manage. Okay, sometimes you are going to deal with these expressions. So I hope you find this, the process easy to understand. What have we done? We just employ integration by parts in order to solve a cycle integral. The ones that when I apply integration by parts, I obtain at the end the same integral that I was trying to integrate at the beginning. In this case, you know how to solve it, and we have seen an example about this. Okay, guys, thank you for your attention.